Hello, everyone. Thank you for joining and welcome to our webinar, Beginner's Guide to RAG with Professor Tom. My name is Yukti and I'll be your moderator today. One of my main jobs at SingleStore is to organize weekly AI webinars. We organize 2 or 3 webinars per week and we demonstrate different data and AI use cases, different tools and technologies that are trending or in. We also go for in-demand sessions. So I also post about these topics every week. So if any of these topics are interesting to you, please feel free to connect with me on LinkedIn so you can stay on top of the loop. Also, I'd like to hear your feedback or ideas or suggestions or on any topics that you'd like to see in future.
Move on here, introduction. Okay, so just 2 slides on SingleStore. But before we do that, do you have a link for the cloud trial? I think it's this one here, isn't it, on the previous slide? So this one here, which you're going to share anyway, and if I click on this, there we go. That's what you'll see. Okay, so this is the link that Yukti will share with you, as well as the other links as well. Okay, which you just saw recently there. And so signing up for this is super simple. So you can use your Google or Microsoft, or if you want, do it the old-fashioned way, using your first name, last name, company email address. And this is the free tier. Okay, so we won't discuss that today because we're focusing very much on Tom's presentation. And Tom, as you know, does these wonderful by hand sessions and no technology required. I mean, that's the awesome thing, okay? And the great thing, because you learn something without necessarily having to use any technology to do that. Anyway, two standard SingleStore slides to show you, and then I'll hand over to Tom. So who is SingleStore? So we often get asked the question. So founded way back in 2011 here, previously known as MemSQL. Okay, so you may have come across the name and the company name and the product used to be called that. So it's been quite a bit of a journey, as you can see. We're at 2024 now, and some milestones along the way there. And so the revenue now in 2024 has reached over $100 million US, okay, ARR, annual recurring revenue. So there's a bit of an inflection point here, as you can see, somewhere between 2017, 2018, that started to grow significantly, and over 350 global customers as well. I think someone asked me the question, is that 350K? Not quite, not yet. Maybe someday we'll get there, right? So, and again, a bit of an inflection point here as well. Between 2019, 2020, again, significant growth there. And down at the bottom, you can see the list of investors, okay? So some of these global names you may recognize. And so these are companies that actually invest in us, and some of them are actually our customers as well. So there we go. And then the second slide, just a little bit on the architecture. So I mentioned MemSQL just a few moments ago, very much focused around OLTP and in-memory processing. Okay, so that's essentially where the product and the company came from. And then a few years back, added the capability to do analytics through columnar storage. So as a requirement, then, you're trying to deal with both OLTP and OLAP. And so SingleStore has this concept of universal storage, okay? The ability to handle and store both of these different types of data. Again, not enough time really to go into it architecturally, but this is a kind of a nice view in terms of some of the capabilities of the product. So we can take data from a variety of sources, such as Kafka, for example, or if you're working with Spark, which we've covered in previous webinars, in terms of transformations using mlib, for example, or maybe you've got data on S3 or Hadoop HDFS. There is a mechanism available called pipelines to ingest data at scale from these various sources. Okay, so this a little bit of animation there, I think, showing the ingest there. We run on all 3 major cloud platforms in the Western world. So AWS, Google Cloud, Microsoft Azure. You can also run on-prem. Okay, so in the portal, that once you've signed up, you'll see on the left-hand side, if you scroll right to the bottom where the organization name is and expand that, just under there, you can actually get a license which will enable you to install SingleStore 4 nodes, full product, free of charge, okay, wherever you want, whether you want to do that on-prem or in the cloud. There's a Docker container as well, available as well. But seriously, I mean, the quickest and easiest way to use the technology is just through the cloud, okay? Just any browser, and you'll be able to create compute resources, create databases. You can work with Jupyter and so on. I mean, as we've covered that in many webinars. So at its heart, it has come from the relational world, but it also supports geospatial, time series, full text, okay, Lucene full text search engine, JSON as well. That's been there for some time. And it's the important point is that we are both MySQL and MongoDB wire compatible. And last but not least, vectors, okay, which Tom covered in one of the previous sessions as well. So vector support has actually been in the product since 2017. Originally, I think the request came in from a financial customer. Significant improvements to that earlier this year, a dedicated vector type, ANN indexing, and so on. Out of the box, the product supports dot product and Euclidean distance. Very easy to code up cosine similarity in SQL if you want to. That's covered in our documentation. And if you want any other form of distance measurement, you can easily code that up yourself. Okay, so we have this thing called Code Engine using WebAssembly. So, you know, C, C++, Rust, for example, just code up the appropriate algorithm, and you can upload that into the database, and the database engine will treat that as a UDF. So that gives you the ability to extend the capabilities of the engine beyond what SingleStore provides. Real-time decisions, AI apps, dynamic experiences, machine learning. We've covered that a lot in previous webinars. Yuki mentioned we do these kind of regular AI events. There's a built-in SQL editor as well for ad hoc queries and dashboards. Okay, so if you work with Tableau and other related technologies, very easy to be able to, you know, JDBC, ODBC standard sort of mechanisms to plug those in. I use Metabase, the free open source version. It's a simple jar file, just need Java, and then within a couple of minutes can be creating pie charts and visualizations. Equally, if you use the Jupyter environment that we have, you can use Matplotlib, Seaborn, Plotly, Plotly Express, and so on. And there's other integrations coming along in the pipeline, things like Dash, for example, and so on. So those are all the key things here. And just one final point. So we sometimes get asked the question, you know, how is SingleStore different from, say, other vector databases such as Pinecone, Weaviate, ChromaDB, etc.? Well, hopefully this diagram, this chart shows you that we do far more than vectors. And we are competitive as well in terms of if you want to use the product purely for vectors, we have that support and it gives you competitive performance. Okay, more benchmarks in the pipeline. We actually have a third party conducting some tests for us, and that will be published in the very near future, I believe. So, you know, this is something that we often get asked. And if you think about it, in an enterprise environment, it's very rare that you just want to use a product for a single purpose, unless you have a very specific requirement, in which case it makes sense. But something like SingleStore, which has a broad range of capabilities, you can use it in a wide range of ways, of which vectors is just one. Okay, so you might want to do SQL analytics, for example, or you might want to do full text search, combining that with semantic search, using the vector support, and so on. Okay, so there's many possibilities there. Okay, and with that, I will stop there and stop the share and hand over to Tom. So thank you for that, and I'll assist with the Q&A now and go dark. So I'll still be here, but you won't see me until the end. So, and there we go. Okay, over to you, Tom. Thank you very much, sir.
Thank you so much for having me here. And it's good to be back to give a lecture on the new topic. And today I'm going to talk about agent, LLM agent, RAG agents. So give me a second to share my screen. And hello, you should be able to see my sketch, I believe. And then, so first, please download the slides, follow this link by dashhand.ai/agent, and you will have all access. You'll be able to download the slides, and if you want, you can follow me today, and that will have some good sketches and some maths for you to solve, hopefully to help you understand some of the intuition behind agents. All right. Okay, so where's my Zoom link? Okay, so to save the bandwidth, what I'm gonna do is to turn on my camera, but you should be able to see my screen share of the screen in Siri, but it just disappear. Okay, here is back now. All right. Okay, so the roadmap for today, this is a roadmap I'd like to take you through. So I will start by talking about 4 common patterns when it comes to LLM agent, and talked about some simple exercise for you to get a feel of how agent might cost you money, and simple math about equation. That's one way to think of an agent, is that agent equal observation plus thought plus memory and plus action. And with that in mind, I'm going to build a framework for agent with you by hand, and then you will see that it's not a super mysterious kind of thing. You can do yourself too. And I'll talk about how it's related to RAG, and go over some common framework. I'm going to show you example from AutoGen, from Crew, from MetaGPT, and then all that. Gives you some example for multi-agent, and if we have time, then we'll do some question answering. So that's what I plan to do today. Akmal, can you let me know whether I sound well?
You sound great, Tom. Thank you very much. And I can
Okay,
see the screen
thank
just
you.
perfectly as well.
All right, so let's talk about the patterns of agent. And agent is you can think of it as an extension of a large language model, and we have a large language model only. So we'll do some prompt engineering. For instance, a prompt could be summarize this article, quantum physics, also known as quantum mechanics, and blah blah blah. And large language model is trained to be able to perform much of a lot of tasks in this case, large language model might say, certainly, here's a summary. And this quantum physics explores atomic particles, wave particle duality, and uncertainty. So it's like a response from the large language model. And then what is an agent? So maybe I would want to share with you some of my personal story that you might know. Some of you who have following my lectures, and so I have 2 sons, and my younger one, Isaac, he just graduated from kindergarten last week. And so I think that he's actually learning. So I asked him, what is 4 plus 7? And he told me 11. So okay, he's really definitely learning some math. And but then sometimes as a parent, we like to ask this kind of really weird question that our child really is not trained to answer. For instance, I ask him, well, if we are riding on a boat and both dad and mom fall into the water, who are you going to rescue first? Have you tried that to your kid, or are you being asked by your own parent? So it's like a difficult question for my 6 years old to answer. He's really not trained to do that, but I force him to answer this question, and he might say, "Oh, dad or mom," and so, but then it turns out he's really not trained to do that, and that's what we do with large language model as well. A lot of times we ask them, large language model 4+7, it does very well, but when we asking a question and trying to force large language model to answer, and he will just come up with the answer that is most probable, and we call that hallucination, that when large language model is forced to just respond to your prompt, no matter how ridiculous the prompt could be. And with agent is that, well, what if my son started to think more independently, and he'll be able to say, hey, do I really have to answer this question? Why do I have to be forced to answer this question about who I want to save first? Yeah, what if I want to save both of you? Then maybe I should get another boat to come or maybe I don't want to save you because you asking this dumb question. So the first ability of an agent showing that this agent behavior is the fact that they could do some reflection, that instead of answering right away or be forced to respond, an agent will be able to think deeper about, well, do I really need to know? For instance, do I need to know more about this request before I answer? Should I answer right now? And in Isaac's example, maybe he could ask some questions instead of answering mom and dad. He questions are really shallow, so he'll be able to think harder about this. For instance, in this case, agent, instead of just responding with a summary, he will say, do I really need to know more about this request before I answer? Okay, I think I do have to ask a question. So instead of responding with a summary, you'll say something like, how many words? Asking a question, how many words of this summary do you want me to generate? So if the agent is to do that instead of just generate a summary, and that is one pattern of being the agent. And not so this reflection. Another way for agent might reflect is that, do I really need to do this? Should I really do this summary? And do I really have to do the same summary? And the agent might realize, maybe based on some other information, this request from a child who is trying to do the homework. So maybe agent would be instead of responding with summary, agent would say, I am not gonna help you. I'm a large language model. I'm an agent, helpful agent, but I'm not helping your homework. So agent might be able to say that. If agent is able to do that, it is more than just a large model. It shows that it could reflection. So this first pattern, I show you two examples. One is to question to the itself. Do I need more information? If I do, I'll ask for that. Second is, do I really have to do that? And then let's consider the other example, a prompt. What is the airfare from LA to NYC? There's a prompt from the user. And with a traditional large language model, it's being forced to answer anytime it's provided with a prompt. It will say $500. Maybe it's correct. And then they will say, oh, yo, you're doing such a good job. If it's not correct, and we blame the large language model, saying that, oh, you are just hallucinating. And with the agent and the model would be saying that, oh, maybe I should check something else. I know that I'm not able to answer. I'm not able to answer this sort of fact question, or based on the current price. Should I check an external source? And then agent will say, instead of responding with dollars, it will say, well, just wait a minute. I will call the airline for you. I will call the airline. I will check the website so I'll use that external tool to the second pattern to, instead of responding right away, I will just hold out. I will try to call the airline. Another example. So what is the airfare from LA? For my family of 5, large language model sometimes might just do math internally, but oh, well, maybe I should use an external app this time instead of just doing my own math. And I will use a calculator. Now I recognize this. This is actually a math problem. I'll use a calculator. Just hold on. I'm gonna use a calculator. Okay, and now you compare this. A regular large language model will just respond to the best it can. And sometimes it's not really designed to answer this question. It just makes stuff up, but a very probable answer. With agent, you get to think about, well, I don't really have to answer right away, because agent has the ability to just hold on and use something else. For instance, use an external app in the second pattern. And the third pattern is planning. So again, in this case, a prompt is to summarize this article. Large language model will say, certainly, here's a summary. But then with agent, we'll think about, well, what is the first step? Is the first step really just go ahead and summarize this article? And it turns out maybe the first step that the agent is trained to summarize the article is that, well, maybe the first step is to know your audience first. Maybe I need to know my audience. I know the step one is know the audience that language teacher will tell you. And now my first step is know the audience. And so in order to do that, I'm going to ask you a question, which is, who is this for? Who is this summary for? Are we talking about a 6-year-old like my son Isaac, or I will summarize it for your high school teacher because you're doing homework? Maybe not. And or is it summarizing for a public audience who is following your newsletter, for instance? So the agent in this pattern exhibits the behavior that is planning, is following a certain step instead of just jumping to the conclusion right away. And the last pattern I want to show you is the multi-agent involving our multi-agent planning. So similar question, can you give me a discount to NYC on the flight large language model? And they'll say, well, it's really not. In this case, I just say, no, I can't give you an account. It's more likely the large language model cannot give a discount. That's rather than can give a discount, but large language models doesn't really know that it doesn't really have to answer this question on its own. Although large language model is always being forced to answer this question. Whereas the agent said, well, who else? Maybe I know I'm not able to, but I do have an option to call for help. Who else can do this better? So I'll say, let me ask the manager. Let me ask the manager here. Or manager is another agent, or manager can be a human. So that is the last very important pattern for you to see that the agent, well, they all share this common characteristics that maybe I don't really have the answer right away all the time when I get a prompt. Maybe I have some other choices then jump into the answer. This 4 pattern exhibit those 4 choices. So that's just as a little review. Can you recognize large language model agent patterns? There are 4 of them, and it is in this particular presentation. So if the asks this question, what is the meaning of life? If it just answered 42, is the hitchhiker's guide to galaxy, and that oh, this is large language model only. It just answer. It doesn't think harder than just answering. And if the large language model says, or agent say something like, I will use a search engine instead of answering this, what's the meaning of life? So this is a tool use pattern. What if this says, first, I'm going to understand the motivation. To understand the motivation, I can ask you a couple questions. And this is what kind of pattern is this? So this is the pattern. The key is this first, and second, and third. They're taking some steps. It knows the first step is something. So this the pattern of planning. I will ask the librarian, it is a pattern of multi-agent. It has the option not to addressing the answer, but it's smart enough to know I could ask some other agent. In this case, a librarian. It's multi-agent pattern. Lastly, please clarify whose life are we talking about? So this is an exhibit. It exhibits the pattern of reflection, meaning that maybe I can answer this question, but maybe I need to know more information. I need some clarification. Don't force me to answer the question right away. I'm gonna ask you some information. So this is a reflection. So this is just a review. With large language model only, you're always forced to answer the question right away. And with some other agent pattern, it could do some reflection. Do I really need to know the answer? Do I have everything I need for the answer? Can I ask a few questions? What is the best way to respond to this? So it's a reflection and tool use. Or maybe I shouldn't be doing this on my own. I could use external tool like a Google search engine. I could use a calculator. And planning, maybe I should have jumped to the conclusion right away. I will take steps. The step 1 is this. Step 2 is this. Multi-agent, I could get some help. So there's 4 key patterns that I like to share with you about agent. All right, let's talk about mining a little bit. Agent is not really a free thing. It can make your interaction with the large language model, OpenAI, API, this kind of expensive. So there's a little review of how much does this thing kind of cost. So in the typical large language model. So have this user query, for instance, what is the airfare from LA to NYC? So there's a query you like to submit to a large language model. And large language model can respond to, okay, $500. And so one thing you need to understand now the most typical way of accounting for this, then we use the API on like OpenAI, is that they count by tokens. So you have to know there are two different kind of tokens. There's a prompt token, there's a completion token. So for this user query, it's actually a prompt we're gonna submit to the large language model. And so this is a prompt token, not a and the other kind for large language model to generate 3 words, $500. It generated 3 words from the prompt. So this to complete this interaction. So it's completion token. So there are 2 different kind of tokens. And so we count for prompt tokens 1, 2, 3, 4, 5, 6, 7, 8, about 8 words. So roughly 8 tokens. And for this completion, 3 tokens. All right. And then typically, let's just say a prompt token is $1 and a completion token tend to be 3 times as much, plus 3 times. It represents that the computational complexity involved in this. For a prompt token, a transformer like architecture is going to analyze this and come up with the code. So the interpretation of what this sentence means is tend to be just one pass of the transformer stack, whereas the large language model, $500, it has to take 3 different passes, each pass to generate 1 token. So it's slightly more expensive. So the rough figure is 1 to 3. And so if we use this math, so this cost of the handling prompt is 8, and cost of handling completion or responding with 3 tokens is 3 times 3 is 9, and altogether 17. So it's very simple math to do this kind of calculation. And with the agent, what does an agent cost? We still have a user query, and this is a prompt token. And then it's same sentence, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them, $1 each. So just say 8. And so for agent prompt, what is the agent prompt? So with agent is that we're trying to let them give agent the ability to act, to think a bit more. So we'll say something, add that to the user query. In the background, agent is going to add the extra things called you are a helpful assistant. You can use Google as a tool use. You are helpful assistant is a reflection that, oh, okay, I'm actually trying to be helpful here to assist you. So these are all the prompt that we have to add to the user query in order for agent to exhibit this extra nice behavior. So these are prompt token as well. Not the completion token yet. Agent not saying anything. Agent just like being told that that's what it is supposed to behave like. So this is a prompt token to count 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 tokens for the same amount of money, $1. So it's 9. And for agent response, $500. Okay, I'm trying to be helpful, $500 in this case. I should do know. Maybe I have to check the database. So this is a completion token here. And there are 3 tokens. And this part of the math is the same. $3 per token because it's 3 times as expensive, roughly. So 9. So then you add them up together to a total cost for this transaction. So 17 plus 9 is 26, all right? So now we kind of operate in the agent realm, and the cost has increased from, what is the previous slide? 17 to 26. Every time you add something to agent prompt to make it think about stuff, make it reflect, make it use tools, make it communicate with other agents in multi-agent setup. This kind of stuff, it all gonna add to your prompt and increase the cost of this. And assuming the response is the same, maybe the response could be more verbose, you're gonna pay for more completion token as well. So this is like simple math gonna come back to give you an idea. Agents is not free. It's no free lunch. I want my son Isaac to act more like agent. I still have to bring him to school and invest time and effort. So it'll take there will be some extra costs associated with something to keep in mind. It's not free. All right, now I want to talk about the agent equation. They're following this pattern, but then This is one equation I kind of like a lot. It's actually proposed by the Meta GPT folks, and to elegantly summarize what agent really is, and in this mathematical formula. So agent equals L. What is L? L and large language model plus O, observation, being able to observe stuff. Observe. How do I say observe? Observation, and then also add thought. Agent can think about stuff. Reflection. It has memory, can remember your past interaction, and remember some other facts, and action, take actions. All right, so this is what agent is. So if you take this, another way to think of it is there's also what large language model is not. Large language model is actually not observing stuff. You have to add the ability. It's not thinking, deeper reflection. It just generates and predict the next word. But it could be you can add to it. And memory doesn't remember. It just, everything is coded in the transformer stack. It doesn't preserve the memory, but you can add to it. And it doesn't take action outside of this generating a word, but you can also add to it. And once you add it all to the large language model, you get this agent. And then we'll think about some of the verbs. So observer doesn't mean you can see stuff, and you could thought, you could think, you could reflect, and memory, it could remember. You need to remember an action you would do. You can do stuff. You can do 1, 2, 3, 4 different choices. So you can specify the action, large language model that to think about and to actually perform afterward. So this is a question. And then I would like to build a framework for us to implement those four this equation. What does it really mean? So there's quite a few frameworks out there. At some point, the designer of this framework think about solving this problem, and we'll just kind of take you through a very easy way of solving this problem to build agent. You can think that all this framework trying to do what I'm doing by hand right now, but just more sophisticated. But the basic idea is not too much different from what I'm trying to accomplish by hand for the next following set of slides. So let's start back to the example of the simple prompt. The user trying to say, please help me buy a house. And with large language model, the problem is it has hallucinate. It thinks that it could just answer. And you're also trying to force it to answer it. The large language model say, certainly, I'm going to help you buy the house. And then a user will say, oh, well, can you really buy me the house? You are just a large language model. You can't. And so in this case, let's just review the cost of just running large language model itself. In this case, this is a prompt. Please help me buy a house. 1, 2, 3, 4, 5, 6. So this prompt token, that 6 prompt token, just submit this as is with no change. This 6 token, so assuming $1 per token is only $6. For the raw LLM interaction, it will be just 6 tokens. If large language model say no, one token is one completion token, costs $3. Large language model can say a whole bunch of stuff too. I'm the large language model. I'm not designed to buy your house and blah blah blah. And then you just pay for those completion token and so on. All right. Now we're gonna want to add the first thing into becoming on the path to become an agent. How does it mean by adding the observation? So in this case, it's pretty simple that I just have this new template, and you will say, well, you need to be able to observe. So I just tell you, well, it really can't observe, it's just a model, but I can pretend you actually see stuff. I tell you what you saw. What you saw is that the user said that, help me buy a house. That's what you observe. So even though a large model is not observing anything directly, it doesn't have a camera, but I can tell you, I can just pretend, say, I write all this at the prompt. You actually saw it. You observed it. You saw a user saying something like, help me buy the house. Please generate a response. So in this case, adding observation is that you could bring in information from the user interface, from a speech interface and so on, or on the file system, and just write what they're supposed to see directly into the prompt here. In this case, user said, help me buy a house. So now you add observation into the large model ability. And so it seems quite kind of simple, just adding that to the prompt. Similarly, how can we add thought into large language model is become more agent. So we just extend this prompt template. So I say, you saw this user say, help me buy a house. You think, okay, now I will tell you what you're supposed to think. You should think that you should take on the role. Role, for instance, think that you are something. You are going to be a helpful, is a popular word to use in the prompt. You want to be a helpful realtor, not just a greedy money-making realtor. And I also want you to think that you could plan. You don't have to just do it right away. You can plan by, for instance, take the step one. What is step one? Being a helpful realtor. I would like to suggest that the step one, as you plan this, is you want to know your client, know your client. So, all right, so all this are a prompt that we're going to add to the large language model, but now that prompt would have given the language model the ability to observe, because I wrote what's supposed to observe there. And you're supposed to think that you are a helpful realtor. You're supposed to plan step one, know your client, with all this extra prompt into it. So this large language model all of a sudden become more like agent, not because it sees stuff, it also thinks stuff instead of just responding right away. A general response in this case is most likely you could say, oh, okay, my step one is know your client. Maybe I should ask a question. Oh, how many people in your family? And what's your budget? Asking this question instead of just saying, yes, I'm gonna help you buy the house and just hallucinate. It's now at least with thought, with observation, is able to do something more intelligent instead of jumping to the answer right away. And to add the memory, what is the memory? You can add the year. Okay, I'll tell you, okay, well, you actually remember stuff. I gotta write down what you're supposed to remember. So the first that maybe you supposed to remember some interaction history for this client that last year you help. You remember, oh, you should help that. You should remember that, oh, you actually help. So I help. I remember I helped that. I helped this client rent an apartment last year. So this is maybe for the information. All of a sudden, this language model knows, hey, I do have a history of this client. It's not a new client. I should behave as such, change my behavior. And then also have some data, real-time data from the database. Maybe that, okay, I know that I just remember there's 3 new houses just got listed. So you write that memory directly into a prompt as well, just listed. So I write this into their prompt. All this together. Now the large language model saw stuff, thought about stuff, has some thought and also some memory here. And you can think of in practice, this history could come from some kind of private database. The data could from such as the vector database to store all the information, interaction history. Data could come from some real-time API that connects to the listing agency's database, but then being added to your prompt. That is what this is doing. And then the next, I'm going to talk about next action, extend this prompt, says, okay, maybe you just don't use a lot of things you might have seen on the internet in the print training to do stuff, but I want to focus on this, a few actions you want to do. One is that, well, you could talk to the sailor agent, So I'm just coding this. Talk to the sailor agent. This is the first action you can do, and I can code this by talking. I'll connect to kind of calling API or connect to some kind of communication, leave a message to the agent for the sale on the sailor side. Okay, maybe I can book an appointment. This is something that a choice for you to think about. All right, so I book an appointment. I would kind of make it more explicit. Hey, this large language model, you have these 2 ideal actions you can choose from, and they have some kind of underlying implementation you can do. So general response, in this case, now the large language model, instead of saying right in the beginning, I will have none of this, they might say, no, I'm not going to help you. Or yes, I'm going to help you buy the house when you just hallucinate. But now so they added to be more behavior of the pattern of the agent into it. So general response like this. And with all that, this is a pattern, a complete prompt for providing some agent behavior. And so in this case, what are these So these are all tokens we're supposed to submit to the large language model, but except that now the large language model have all the things it needs to behave like an agent. It has thought, it has observation, it has memory, it has a set of action it can choose from. But this is all prompt, it's not really completion tokens. Because then the agent will say something like, well, given all this, maybe I'm gonna talk to the third status agent, because based on this is one of the choices. Those will be completion token. But for now, these are the complete prompt, and there's lots of tokens. How many tokens? I wrote it down actually. So these are 52, about 52 words and 52 tokens. Each token costs $1. So total cost is $52. By implementing this agent, that it could act a bit more intelligently like agent, but the cost is, let me go back. In beginning, only $6 by not having any agent behaviors. But now, once add 4 key components to this prompt, our cost has gone up to 52. All right, from 6 to 52. So it does cost something it might be surprising to some of the people trying to use agent the first time is how costly it is. Also, this is just one interaction. If you have a dialogue and every time the agent says something back to you, this prompt has to be provided as well. So so the behavior can be consistent. So it'd be basically 52 times a lot of interactions. So that's how much an agent might cost. Now we're gonna do a test program using this. So suppose we apply this pattern, this agent formula to this. Please test this program llm.cpp. So for the observation part, will be llm.c with maybe 500 lines of code. So how can agents see code? We write those code directly into the prompt. That's how it sees stuff. How can agents think that what it is trying to do? So add row. So now I want to be a tester and also based on automation. So now it knows it probably become primed to act like this. And so you remember the previous version of this code, so you can find the differences. Maybe you will do regression testing. So the previous version, how does it even remember it? Because we have to add all the 500 lines of code right directly into the prompt as well. And you can write test cases, this action, write test cases. You can compute coverage to make sure it's good coverage. So these are something that you write directly into a prompt as well to tell this. And then we do some accounting. So now the prompt token, how many prompt tokens? If we add all 500 lines of this source code into this, so this will be a lot of tokens, for instance, 5,000. And maybe a more refined tester automation description that we want you to think or take steps, and then maybe 100 tokens to do that. Another 5,000 token for previous version, and hopefully large model will be able to compare them, and some more actions will tend to be fewer. And so you can start to see that things that can scale pretty quickly is how much memory you put into the agent, or also how many observation you put into the agent. So this can add up like this. So roughly about 10K token just to implement this. So it could get pretty pricey as well, something to think about when you actually go for agent. If you have unlimited budget or you run your own large language model locally, then it doesn't really matter. But you're trying to use OpenAI API, you have to pay for it. Something to think about when you choose the framework. And for the RAG, and then I think RAG, in the previous talk about RAG equals query, prompt, and context. I give you some example that we're starting from query, and query will be added into to the question. And some prompt will be, I have this example, you are a helpful and respectful and honest assistant. And then your answer should not include any harmful, unethical. So these are actual prompt added to this query. And you also want to be socially unbiased and positive in nature. And then also we add a database into this context. So how much does Tom make? They will, based on this database, look at Tom 50, and large language model has all this information, will be able to say 50. So this is very typical RAG retrieval-augmented generation. But with this, you can start to see some behavior of agent as well. So how this related to the agent, you can see this part when I put Tom 50 prof. This is a context information, like pull from the database and put it there, retrieve from the database, put it there. So this, if I want to code it in our agent framework, so this is where the memory is, memory, all right? And then here, all this is that I want them to think, agent to think that you are assistant, you are helpful, you are not unhelpful. And here also, please answer. This is somewhere you can add an action. I want you to answer it. It's one action. Is you please answer. But you could imagine that with real agent, you will say, please also say something like, oh, you might not need to answer. You can ask follow-up question. So it's action. And deadly, what it doesn't do is that it doesn't have a multi-agent yet. It doesn't, in this particular prompt, doesn't give this RAG ability to consult without agent. If you add that, it becomes closer to the agent system. Hopefully, in this quick example to show you how RAG is related to agent in this case. All right, so skip this. All right, this is RAG versus agent. I just did this on the previous slide. All right, talk about quick framework. So we have lots of framework right now. And then, so three of them are gonna talk about agent, called the AutoGen. So this is the, then we have this Meta GPT and Crew AI. And so when you remember back to the front end work, the time when you learn about front end, there's Angular, React.js, and Vue.js. In my opinion, it kind of have a pretty a similar mapping that you can think about. The choice is becoming your programming experiences. And so for the React framework, kind of like OOP, object-oriented programming, you're trying to create some subclasses to create an agent. So in Meta GPT, it's kind of like that. You were trying to, and then for this AutoGen, it's kind of like you have the template, you filled it in, kind of like Angular. And Crew is a lot of configuration-based programming. It's similar to Vue. And so the reason why I want to map that to the framework is that for these three different framework, you might think there's a lot, but all they're trying to do is just do one thing, trying to generate certain thing. What is trying to generate? Generate a big prompt. This big prompt with all this agent behavior, thought, memory, action, multi-agent coordination, and so on. So generate a bunch of prompt tokens from just one simple stuff, but generate a bunch of tokens to add agent behavior. And all this kind of costs money though. And then we feed them to a large model. So this large model previously is just very dumb in terms of just responding stuff all the time and hallucinate. With all the extra agent prompt token, it will exhibit a bit other behavior. And similarly, when we have all these three framework, what they're trying to do is also generate. What does it generate? Generate the HTML tag. So they all generate just HTML tags. And then we're going to have a browser rendering engine, take those tags and to actually display, draw user interfaces and so on. So, and that's something hopefully demystify what this framework do. And all trying to do just trying to generate these prompt tokens for you. And for instance, let's take a quick look at AutoGen. So they'll have this thing that you can define. So conversable agent. So I have say I want to define Kathy and provide some system message. So write explicitly, you are Kathy, and then you are a comedian. So write that, and this you can see that when we write this form, I'm teaching Kathy what to think. So this is adding some thought into this. And these are some technical stuff. So I want the model to be as a GPT-4. Why? Because we're gonna send this message to this model. We are use this framework to generate this prompt, but eventually still send to this model we want. And there's some temperature, how diverse, and then API key so you can pay for it. And you don't want other people to see your key. So this is a very basic defining using AutoGen framework. Eventually, you just write the system message yourself like this. You are Kathy, a part of a duo comedian. So if you don't want to write that stuff, you can see that this is a default system message. And then I included this just so that you're not too scared by this. But then we can learn a lot about this. For instance, this default message for this framework, you can see evidence of thinking. So where are the thinking part? It's kind of hard to read, but let me just see. So here, solve the task step by step you need to. It's about high level thinking, taking step and planning. If your plan is not provided, explain your plan first. This is like adding some thinking behavior into this prompt. And saw is that, okay, you can check the execution result returned by the user, this observation. If the result indicates there's an error, fix the error, and output the code again. So we'll add that result into the prompt somewhere as well in this template. And then there's a can, is the action here. You could browse and search the web, download with the file. You write that into the prompt as well. And this only costs money. You can count the number of tokens to system message. Each token costs some money as well. So it's, even though it's extended, but you have to keep the cost in mind. And Crew AI is another framework. You could have write this row more explicit with all this fill in the blank as well. And then instead, you have the role is writer, and a goal is to narrate compelling story and so on. So, but I'm gonna code this up using this framework as well. Where can you see evidence that adding thinking ability? They want you to think you are the writer, and then for memory, and the memory is different color. So this is memory is true. So the set is flagged to true to dump a lot of stuff into the prompt. And the can is the search tool, can use a search tool. And saw is that you could, this is topic, when the end user specify the topic, you kind of plug it into this location in this template. And so all this eventually just going to become a gigantic prompt here. And that, so agent is help you, this framework just help you write this prompt so they have to type this prompt yourself. And similarly, Meta GPT is that you define these classes. And for instance, you want to invoice OCR, an assistant that could scan your invoices. And then you have to subclass this role and do some OOP. And it's more production kind of stuff. And with OOP, you need, you give it a name, and you want it to think about your assistant. And then you have a goal. So those, all this add to the thought of this also plan. Some constraint and specified languages. So this field, again, all this is going to eventually compose into a really big prompt too. And you pay for those prompts. But you could also define the action, a synchronous action, because it's some IO bound task to actually run the OCR and get some result. And it return the invoice message, but also you write this OCR result into somewhere, then file path, and it's add the observation, and eventually add that into the prompt as well. And you could, your prompt can actually blows up as if you decide to add everything into it. So this is the memory here. But then you treat this memory, it could be tied to a database, but eventually you still decided how much message from your memory to put into the prompt. So you don't think you cannot put everything. You can just really blow things up. At the end, to talk about multi-agent, and the equation kind of expand. If you add communication, SOP, and the environment economy, you get multi-agent system on top of the agent. But then just quickly give you an idea, what does it mean? Eventually, at the end of the day, you're still talking about adding them into the prompt to coordinate them. So Alice and Bob write the program together. In the multi-SOP will define that, okay, for Bob, Alice can say that you are actually a test. You define, you are the coder, but I want to know that, hey, you are working with Bob as a tester. So that is a view of Alice. Similarly, in Bob, you define like how you think you are the tester, but you know you're working with Alice, who is a programmer. So you write that directly into the individual prompt. Eventually, the framework will kind of do that for you. But at the end, you just have something that looks like this. And for communication, and how do we facilitate communication? Again, it's still right in the prompt. So you'll write that for Alice that, well, you told Bob that you like to test this code, told Bob to test. And Bob remember the communication is that Alice said, I need to write 3 test cases. You explicitly write all the communication history that matter into their memory. That's how they facilitate communication between multi-agent. Eventually, you also add an environment to it. How can they code together because they share? I saw that this code LLMCCPP, I saw all these 500 lines. So the environment allow you to read the files, open it up, and dump the file content into the observation part of the agent. So you add the environment they both share. Once you have that, you get a multi-agent and have question answering. A little bit longer than I wanted it, but I hope that you got the pretty good sense of how the key component of the multi-agent framework. Thank you.
Thank you. So we will now start with the Q&A session. We have Professor Tom, who's going to answer everyone's questions, and we have Akmal, who is going to answer SingleStore related questions. So guys, please feel free to chime in, and we will take up questions. So yes, the recording will be available, Yusuf. I just answered one question for you guys. So we have one question from Vignesh Iyer. They say this is the most. Oh yeah. Oh, sorry. It's not exactly a question. It's
Observation.
like a compliment. They say that is the most intuitive explanation I've ever seen on this topic. Thank you very much. So
Thank you.
oh, that's really nice.
Yeah, I think this
So
is why these sessions are so valuable, because you think rather than using technology, you use your brain, you use a piece of paper, you use a pencil, you work it out for yourself. And that's the great thing, okay? So you don't rely on the technology. It's intuition and thinking about the problem and then coming to some conclusions in that and working it out first before applying it. And I think that's always very valuable. Just my opinion. So
Thank you. Thank you for your
like
feedback.
a lecture. It's just like a lecture. So
yeah.
it's very nice. So, all right. So if we don't have questions, Akmal did a very amazing job in answering the questions, and we are almost at the top of the hour. So, I think
Yeah, I think anything that comes up, we can
we just have one
follow it up.
question.
As you mentioned at the start, so our mission is to answer 100%
Sorry.
of the questions, even if we don't get through all of them at this time. And given that we
Right.
are at the top of
We
the
do
hour,
we do have
you want to
questions
do
now.
the prize draw, yes. So,
Right. So I think we can just take up one question from Satish. They say, are there any NLP, NLU use cases for enterprises which uses only vector databases like SingleStore and some type of knowledge graphs without using LLMs? I think this can be addressed to Akmal.
Yeah, Akmal, that's your
you
question.
caught me there.
Yeah, that's your question.
Are there any use cases for enterprises which use only vector like SingleStore and some type of knowledge graph? Actually, you mentioned this right at the beginning, Yukti. We've got a webinar coming up on knowledge graphs very
Oh,
soon.
yes.
So that is worth attending. And so I'd highly recommend that. So we often get asked about graph support in the product. So I mentioned all the other multi-model capabilities. Graph is often a request. SingleStore does recursive CTEs, common table expressions. So it doesn't support graph per se in the sense like Neo4j, for example. But you can do graph-like processing. And this webinar on knowledge graphs, I think, will be very useful for anyone that's interested in that type of processing. And that's coming up. When was that, Yukti? Do you remember? It's soon, isn't
On
it?
June 19th, 18th,
Oh, okay.
I'll Akmal, if you can share your slides, I can just, let
Okay.
everyone know those who joined
That's
late
fine.
and just quickly announce the raffle winner. And thank you guys for such amazing responses, and we are really overwhelmed. And Tom, there's like a lot of people saying that it was an amazing lecture. So
Yeah.
that's what. So, all right, just quick notes before I announce today's raffle winner. Akmal, are you able to share your slides?
Yeah, Tom, could you just, if you could stop sharing, and then I'll share my screen. That's great. Thank you very much. I'll try and do my very best on that one. I've always got too many windows open. And just have a look.
Can you I added a slide for our Unfreeze Your Data Iceberg campaign on 26th. So if you can just go with that.
Okay, this one I think is what you wanted to.
Yes, absolutely. So
there we go.
All right. Thank you so much, Tom. That was an amazing session. So moving forward, our product and engineering team recently surveyed our Fortune 1000 customers, and they determined that over 90% of new Gen AI initiatives ended up either being too hard, be too slow, or C, it's just too costly. Because the majority of their enterprise data is stuck in iceberg or structured in a way that the hype around vectors is not exactly working. With their current database or their current system. So please join us on June 26th. Our engineering team is launching a new product features that will enable companies to build enterprise-grade Gen AI apps on iceberg-like data. You can think like data on Snowflake, Databricks, Azure Data Lake, etc. that can get milliseconds of response time. So sign up right now. This with the link that's available on your screen to thaw your data and join the real-time AI evolution. So the link is also available on our landing page. So if you visit www.singlestore.com, it will just directly take you there. It's right in front of your eyes. So if anything sounds interesting to you, please RSVP right now. I hope to see you all there. So moving forward in the best interest of time, the announcement that everyone's been waiting for, today's raffle winner, it goes to Olga Lagunova. She is the director and of Global Advanced Analytics at AbbVie. Congrats, ma'am, and thanks for joining. And if that's not you, please do not give up. We are going to announce one more AirPods and Meta's Ray-Ban winner by the end of the day for anyone who has tried out today's demo. And you could have signed up at the link that was provided to you during the webinar, and you can be eligible and be entered to win. I thank you, Tom, again for the presentation and the demo. We really value your time and energy, and thanks everyone for joining. Thanks, Akmal, for answering everyone's questions so patiently, and take care. Thank you so much.
Thank you
Bye-bye.
so much. Bye bye.